Hi everybody, welcome to today's Tuva Science Connections, where we're going to be diving into cycling sunspots as our students are exploring HSESS 1-1, where we're asking them to develop a model based on evidence to illustrate the lifespan of the sun and the role of nuclear fusion in the sun's core to release energy that eventually reaches us here on Earth in the form of radiation. But in order to build that model or to better get a sense of how to build that model, it can be helpful for our students and really for all of us, right, to have a sense of what are the factors, the drivers, the components, the things that we should include within that model, and how do those vary, how do those adjust, how do they change over time, things like that, as we're looking at lifespan, like we're looking at building a model that's questioning about time. So we could use data, right? So we could ask questions like, how do the number of sunspots vary over time? And use those data, use that pattern to make a sense of when will the next maxima be of sunspots? When will it occur? So that we can incorporate into our model a sense of sort of predicting forward, using data back and predicting forward. All these kinds of things are the kinds of things that your students can work with as they're engaging with the Tuva activity called Predict Sunspot activity. So let's dive into this data set and get a sense of what we can do with it. So to orient us a little bit to the data set, the data are from the NOAA Space Weather Prediction Center. There are 325 cases within the data set, and a case is sort of observations each month of how many sunspots there were. And there are 4 attributes that we have information about the sunspots. And this is information that's helping us get a sense of sunspot cycle, but also space weather, like what's coming off of that sun that's impacting the weather in space. And we can use this information, right, to get a sense of changes over time or how those changes vary with one another. So we've got our time attribute of year and month. We have our sunspot numbers, those that were observed. We have the observed radial flux, or the slope in solar flux units. And we have the smooth geomagnetic disturbance index. But let's dive in and start playing with the data to get a sense of our question of how do the number of sunspots vary over time. So let's get our time axis going. Let's drag over the number of sunspots observed and get a sense of what might be happening. So we can very quickly start to see that, oh, there's an up and down. There's a cycle, it seems, to the number of sunspots on the sun within this cycle. And to dig in and get a bit of a better sense is we can add reference lines to be able to eyeball better sort of where these peaks are. Now, I'm going with the peaks because it's just sort of helpful to see a high point. You could go with the valleys, the low points, whichever you'd like. And this is just an informal analysis, right? I'm just getting a sense of kind of, okay, where, if I were to eyeball kind of where this peak was happening, where might it be happening? And depending on kind of where we put it down, we could get a sense of, okay, it seems that there's about a 9 or a 10, 11 year gap between our first peak on the left and this peak in the middle. And then similarly doing an informal analysis, exploring our data, you can get a sense of, okay, so this one seems to be on about an 11 or 13, 14 year cycle. So now we can get a sense of, okay, sort of what is the time frame that's pretty consistent time frame of like it's around 10 or 11 years, sort of 9 to 14 is our range, to get a sense of sort of the time period between these peaks. Now we can build that forward to think about our next question of, can we make a prediction about when the next maxima may occur? So we're predicting into the future, so we need to extend out our x-axis, and we can add in more reference lines, right? We can start annotating our data to say, okay, so if we were thinking the range might be anywhere from sort of 9 to 13, 14 years between the peaks based on these data, and what are these data we're going from? Okay, so let's take a pause for a second. We have data from 1991, January of 1991, and then we have data from January of 2018. Okay, so that gives us a sense of what the data are that we're looking at. And so we can think sort of the lower end of the range might be 2022, the upper end of that range might be somewhere in 2027. So by different sort of annotations of the data and manipulating the data, oh, these data, maybe we should actually have them as a line graph rather than a scatter chart, because we're looking at time as our x-axis. It's an ordered variable. So that gives us a sense of things. So we can kind of play around and we can manipulate. We could extend it by adding in some of these other variables in. So it's kind of hard to see in the line graph. So let's go back to a scatter chart. Oh, blue's still really hard to see. So let's change this over to red so that we can see a difference in the color of the observed radio flux. And as it, we're like, oh, so here's some other interesting patterns that we can start to see. So by exploring the data, we can jump back in and get a better sense of what's going on some of those components that will go into our model. So how do the number of sunspots vary over time? Well, within this data set, it seems that the number of sunspot cycles on sort of a 9 to 14 year time scale. And we could drill in more formally and get even a tighter range of what that might be. And using that time range, when might the next maxima occur? Okay, well, we could predict that it might occur sometime between 2022 and 2027. And we can keep exploring the data to better understand those different components we want to integrate into our model. This is obviously just one of many earth science lessons and connections that we can make with data. So I encourage you to check out the Tuva Science Content Library. Look for other performance expectations, look by different specific science topics that you're looking at. Just get in there and find some other fun things to be able to make these science connections with data with your students. As always, reach out if you have any questions. I hope you have a wonderful day and enjoy playing with the data. Thanks.